integral some more. Okay, let's see. There we go. All right. Okay, so our main integral of indefinite integrals that we have so far, we're going to be adding to this list through the rest of this semester and for the first third of next semester. And okay, we'll go through them in a minute, but remember that an indefinite integral and I think of that as being the same thing as an antiderivative. This is a function in case you need just one of them. Or if you want them all, it's a family of functions. And a definite integral is a number. Okay. So, yeah, in math, it's really important to keep in mind what your objects are. All right, so we know that the integral of a constant times a function, C, big C, and K in this list are constants. You can pull a constant that's multiplied by a function out of the integral. Doesn't change anything, or it doesn't change the meaning. Okay.
Can you please repeat that, Professor Candy?
Okay, I forgot what I said. Well, let me just start over. Okay. First, little c, big C, and K in this list. Can you see my screen, first of all?
Yes, ma'am.
Okay. If you have number one here, if you have the indefinite integral or antiderivative of a constant multiplied by a function, then you can take the constant out of the integral. Okay, so number one, integral of c times f of x dx is c times the integral of f of x dx. If you have two functions added, the integral of the sum of two functions is the sum of the integrals. Products does not work this way, but sums and differences, it does work that way, so that's nice. The antiderivative of a constant is the constant times x, and you still get to add on an arbitrary constant. The antiderivative of x to the n dx is x to the n plus 1 over n plus 1 plus c, provided n is not equal to minus 1. We started talking a little bit about what to do if n is equal to minus 1 yesterday, and we'll come back to that shortly. Antiderivative of the sine is minus the cosine. Antiderivative of the cosine is the sine. Antiderivative of secant squared is the tangent of x. Antiderivative of cosecant squared of x is minus cotangent. Set that off. Okay. Antiderivative of the secant of x times the tangent of x is secant of x. Antiderivative of cosecant x times cotangent x is minus cosecant of x. and any derivative of 1 over 1 plus x squared dx is the arctan of x plus a constant. And then any derivative of 1 over the square root of 1 minus x squared dx is arc sine of x. Okay. So we have those so far. And so we're going to practice on both some indefinite integrals and some definite integrals today. Okay, somebody's came in. Okay. Okay, so problems here. Find the general indefinite integral of integral, I don't need the of, okay. This is, my function is 10x to the 4th minus 2 secant squared x. Okay, it says find the general indefinite integral. That means I want the entire family of functions that serves as any derivatives of this function. Well, I've got two functions added there. So I can break this into the sum of two integrals using property 2. Okay. So that's going to be the integral of 10x to the 4th dx plus the integral of minus 2 secant squared x dx. That's property 2. And then we can use property 1. That's a property that says if I've got a constant multiplied by a function inside the integral, I can just pull the constant out. So I can pull the 10 out and I can pull the minus 2 out. So this is going to be 10 times the any derivative of x to the 4th dx minus 2 times the integral of secant squared dx. Okay. Well, for x to the 4th, we can use this rule about any derivative of x to the n. This one right here. N here would be, so this is going to be 10x to the 5th over 5, and then minus 2. Any derivative of secant squared is the tangent of x, because the derivative of tangent x is secant squared. So this is 2x to the 5th. And that is the entire family of antiderivatives of 10x to the 4th minus 2 secant squared x. Okay. And it's also the most general most general indefinite integral. Yeah, I sort of use the integral and antiderivative interchangeable.
We completely lost you there.
Where?
Whenever you were, I don't know, you said something.
It was right after you said that what you just wrote down is the general or integral for that family of functions.
Okay. Okay, wait a minute. You mean that my microphone went out?
Yeah, you've become distorted.
Okay. I think, yeah, I don't know what the deal is here, but
I think your signal is weak.
okay, well, I'm going to go sit next to my router and Wi-Fi thing. Okay, let's see if that helps. So I'm moving.
Say,
Yeah.
Professor Kendi, I
Yeah.
know that on Friday, I was telling you about how Apple may release a update that may fix that issue. And
Really?
yeah, and I noticed that yesterday there was a new software update for iOS devices. So that said it's supposed to help fix bugs and such.
Great.
So,
They haven't sent it to me.
okay. Well, when you get it, it would probably be wise to go ahead and install it because, I mean, even if you get it right after class, it's like a 1 minute download. So,
Okay.
mhm.
Well, I'll check it out. Yeah. So you think maybe this microphone issue is because of that update?
It very well could be.
It might be. Yeah, it might be.
Okay. I don't. Let's see. Well, looks like my lights are on. So, all right. So let's try to keep going here. So let me see. Okay. So I'm just going to start over. The integral of the indefinite integral of 10x to the fourth minus 2 secant squared x. Okay, first of all, using property 2, because this is basically the sum of two functions, I broke it into the sum of the integrals. Okay, so I went from one integral to the sum of two integrals there. Then using property 1, I can factor the 10 out of the first integral and minus 2 out of the second integral. And then in the next line, take any derivative of x to the fourth is x to the 4 plus 1 over 4 plus 1. That's where x to the fifth over 5 comes from. Any derivative of secant squared is the tangent of x. Okay, so 10 over 5 is 2. We wind up with 2x to the fifth minus 2 tangent of x plus a constant. And that is the most general antiderivative of that function. Okay, did I come through that?
You broke up when you asked.
Time. Yeah, okay. Okay, well, I'm going to try another one. And well, after class, I'm going to try rebooting and see if that helps. And then I'm going to look for an update.
Dr. Kennedy, what did you say
And
that
I'm going to be
answer was called? Did you say that this was the antiderivative of that, or what did you say?
Yeah. Okay, this is I'll write both of them. This is the most general indefinite integral of 10x to the fourth minus 2 secant squared x. And it's also the most general antiderivative Okay, it's both of those things. Antiderivative, like the derivative. Okay, I didn't spell that right. Derivative. Okay. Try another one. Okay, so this time we're trying to find an indefinite integral of cosine of theta over sine square of theta. Sorry, my cat's in here knocking things off the table. All right. Now, there's nothing in the table that tells you what to do with this function. That's the quotient of the cosine and sine squared. Okay. Nothing in the table. Go back and look. All right. There's nothing in the table that tells you what to do when you have the quotient of two functions or the product of two functions. Well, except for maybe that very special product. Okay, so what do? Well, you change the form of the function. You don't change the function, you just change the way it's written. And the cosine of theta over the sine square of theta, I could write as cosine of theta over the sine of theta. Oops. Theta times the sine of theta, and then break it into two fractions, a product of two fractions. Okay, and how does that help me? Well, cosine over sine is the cosecant, and 1 over the sine, no, cosine over sine is the cotangent. 1 over the sine is the cosecant. And how we integrate that function, cotangent of theta, cosecant of theta, is in the table. Okay, it's right there. So the integral cosine theta over sine squared theta d theta is the same as the integral of the cotangent of theta times the cosecant of theta d theta, and that's equal to minus the cosecant of theta. So minus cosecant of theta is an antiderivative of this function. The most general antiderivative, or the most general indefinite integral, is that function plus any constant. Any questions? Okay. Are y'all still there?
Yes, ma'am.
Okay, great. Okay. Let's do another one. Now this one has the numbers on the integral sign, the 0 at the bottom and the 3 at the top. That means this is a definite integral. And that means we're going to come out with a number. And we're going to use the fundamental theorem of calculus. If we have no numbers, like in the previous problem, it's an indefinite integral. If we do have numbers, it's a definite integral. Okay, so this one, again, it's a sum of two functions. Okay, so I can break it up into the sum of two definite integrals. And I need an antiderivative of x cubed. What's that?
X to the power of 4 over 4.
Yes, thank you. And then, okay, I want to evaluate that from 0 to 3. That's what this vertical bar with the two numbers mean. Notice it's the same two numbers as we had on the integral, and the 0 is at the bottom of the integral, so it's at the bottom of the bar. The 3 is at the top of the integral, so it's the top of the bar. Okay. And then the next one, I can pull out the -6, and then an antiderivative for x is x squared over 2. And that gets evaluated from 0 to 3. So let's see, let me clean it up a little bit before I evaluate here. That's going to be -3 okay. And well, 3 to the 4th is 81. Let's just put this in first. So it's 3 to the 4th over 4 minus 0 to the 4th over 4. And then -3 times x, x is 3 at the top. Oops. That 3 stays. And then 3 goes in for x, and then 0 goes in for x. Okay. And so that leaves us with 81 over, 81 over 4. 3 to the 4th is 81. And then 3 times 3 squared, that's 3 cubed, so that's 27. And I guess I'll do the arithmetic. Okay, what's 27 times 4? 28, 108. So 81 minus 108 over 4. And that's equal to 27.
It will be -27, right? Or -27 over 4.
Oh, mine. Yeah. 108 is bigger than 81. Okay. Okay. Okay, let's see how we did on time. Fine. I'm just practicing, okay, on these. Remember, this material, not on the exam, will be on next week's homework.
Dr. Kennedy,
Yeah.
could you go over those vertical lines just for a second, if you don't mind?
Sure. Sure. Okay. So I broke this integral
Can
into
you
the
say that
sum of
again? You
2.
broke
I
up at
took
the
the
beginning.
antiderivative of x cubed. That's x to, okay. First thing I did was to break the integral into the sum of 2 integrals. That was here.
Okay.
Okay, I broke the big integral into the sum of 2 integrals. Okay, I can do that because of rule number 2. I got an antiderivative for x cubed, that's x to the 4th over 4. And here, I only need one antiderivative. I don't need the entire family. But what does this bar mean? Okay, that means I want to do, okay, so.
What I'm getting
Remember we have,
from the work that we just did is that basically the 3 and the 0 became our x value.
yes, those are
Is
my
that,
endpoints.
is that essentially what we did there?
Right, so this is basically f of b minus f of a.
Okay.
Okay, in fact, this means this really. Okay. Oh, this is capital F. This function is capital F. That's the antiderivative for x cubed. Okay, that's capital F. And when I do this vertical bar with the 3 and the 3 at the top and 0 at the bottom, what I'm really thinking of is this is f of b minus f of a. B is 3, a is 0. Okay, does that clear it up?
Very much. Thank you.
You're welcome. Okay, so let's do another one. This is another definite integral, and I never did like that, whatever it was. This is the integral from 0 to 2 of 2x cubed minus 6x plus 3 over x squared plus 1 dx. Okay. Okay. I have the sum of 3 functions here inside the integral. So I'm going to break it up into the sum of 3 integrals. I am allowed to do that. Okay. And now let's pull out the constants, the multiplied constants. I'm allowed to do that. I use property 2 to go from there to here. Now I'm going to use property 1 on each one of these definite intervals. So first one, I can pull out the 2. And the next one, I can pull out minus 6. And in the third one, I can pull out 3. That's a dx. Okay. Okay, now I'm ready to take my antiderivatives and use the fundamental theorem. This is a definite integral. That means our answer is going to be a number. Okay, so if I have x cubed, antiderivative and antiderivative of that is x to the 4th. And then I'm going to use the fundamental theorem. So I'm going to put, so this is capital F. But then I want f of b minus f of a. So that's really what this bar with these numbers is telling me. And I do the same thing for the next one. And the same thing for the next one. What's the antiderivative or an antiderivative of 1 over x squared plus 1?
Well, ma'am, you could go with x minus x to the minus 1. No,
Okay.
plus 1.
Well, then yeah, but that looks a little
Isn't it the arctangent x
Yes.
plus
Okay.
c?
Yes. It's an arctangent. Good. Who was that?
Kenya.
Oh, good for you. Yes. Okay. It's in your list. In fact, all right, this writing 1 over 1 plus x squared as 1 plus x squared to the minus 1, that's a useful thing to do a lot of times. But it makes a difference that you have, instead of just, well, first of all, that would give you this n equal to minus 1. We don't know how to handle that yet. And I've got, instead of just x, I've got x squared plus 1 raised to the minus 1. So don't really know how to handle that yet. Okay. But fortunately, okay, so this is arctan of x.
Dr.
Okay.
Kennedy, your screen froze. Oh,
Times
oh, we're back.
2 to the 4th. Okay. Well,
Oh, you're
I will
good.
look for,
Continue.
okay. Okay. Oh, the joys of technology. Okay, and then this one's 2 squared over 2 minus 3 times the arctangent of 2 minus the arctangent of 0. Okay, so let's clean that up. Now that is our number right there. 2 people entered the waiting room. Okay, wait a minute. Let's see who these are. Oh dear. I'm not the only one having problems this morning, I guess. All right, so let's see. 4 times 2 is 8. So that's going to be minus 12. And then we have, okay, arctan of 2. Well, that doesn't correspond to a special, well, let's see, wait a minute, maybe it does. Arctan of 0, 0. Arctan of 2. No,
Professor Kennedy, I
Yeah,
don't think Mr. Miller was allowed in.
okay. Let me go back. All right, there. All right. Thank you. Arctan of 2, yeah, okay, that does not. Huh?
I just said not a problem.
Okay. Okay, so arctan of 2 does not correspond to a special angle, so it's just, so I'm just going to leave it arctangent of 2, okay? Arctangent of 2 exists. Arctangent of any number exists. Because arctangent has domain all the
Can you please repeat that, Professor Kennedy? Can you
No,
please
the
repeat
arctangent.
what we're saying about the arctangent?
Okay, I'm trying. The domain of the arctangent function is all, let me write it. Is all the reals. Okay. So that means so arctan of 2 is a number. In fact, okay, in my little picture, there would be 2 arctan of 2, whatever that is. So leave your answer in this form. Oh, did enough come through
Yes, ma'am.
that time? All right.
Yes, ma'am. It was just when you were writing the, or when you were drawing the arctangent.
Okay. Okay. Let's try another one. Let's see, how am I doing? Oh, plenty of time. Tomorrow, we're going to get our first little technique of integration. But right now, we're just practicing on what we've already had. Okay, so this is a definite integral from 1 to 9 of 2t squared plus t squared times the square root of t minus 1 over t squared. All right. That is inside that integral. We basically have the quotient of two functions. And there's nothing in our list. Oh boy, go back a ways here. There's nothing in our list that tells you what to do when you have the quotient of two functions. In fact, there will never be anything in any list that will tell you what to do when you have the quotient of two functions. You have to figure out a way around it. Okay, so that means I'm going to try to write the function in another form. And so let me just pull it out. I've got 2t squared plus t squared times the square root of t minus 1 over t squared. And well, I've only got one term in the denominator, so I can break that fraction up into the sum of 3 fractions. So 2t squared over t squared plus t squared, and I should write that square root of t as t to the 1/2 minus 1 over t squared. Okay. Now, instead of having a quotient, I have a sum. And let's clean it up. 2t squared over t squared is just 2. And t squared times t to the 1/2 divided by t squared is t to the 1/2. And okay, 1 over t squared, this time it's just plain old t squared down there. It's best to write it as t to the minus 2, okay? And I know how to integrate that. I know how to integrate that. And I know how to integrate that. So now, the integral from 1 to 9 of 2t squared plus t squared times the square root of t minus 1 all over t squared is the same thing as the integral from 1 to 9 of 2 plus t to the 1/2 minus t to the minus 2 dt. Okay, and then I can break that up into a sum of integrals, or you can just do it in your head if you wanted to. I'm going to
That's
go ahead.
going to be 2. That's going to be 2 plus 9 to the 1/2 minus 9 to the negative second. Second minus all over 9 to the second. No, wait, no, all over 9. 9.
Oh, I think you're jumping the gun. Okay.
Oh,
We want to antiderivatives first. Okay, but let's go back. Okay, Mr. Britton, Mr. Drake, why don't you? What's an antiderivative of 2?
antiderivative is 2x.
Or 2t? How about that? Here.
2t.
Okay. Okay, so let's go straight to the antiderivative. You can do that too. Antiderivative of 2 is 2t. What's the antiderivative of t to the 1/2?
That would be that's a tricky one because it's a fraction.
It would be
Actually,
2 over 3 t plus 2 divided by 3. My bad.
Yeah.
Yeah.
Well, 2 to the n plus 1 over n plus 1. So t to the 3/2 over 3.
I knew that. It's just that the fact that it's fraction is a pain because you can't put a fraction under a fraction.
Well, do it.
At least that's what I've always been told.
Do it in 2 steps.
Doesn't it end up being 2t to the 3 over 2 over 3?
Yes, it does. And I'll write that in a minute. Okay, what's the antiderivative for t to the minus 2?
Is t to the minus 1 over minus 1.
Yes. Okay, so now we have our antiderivative. All right, so this is this big F of t in the fundamental theorem. And now, because it's a definite integral, I don't just stop here. Put this vertical bar with these numbers, because that means I want to take f of 9 minus f of 1. Okay. And I'm going to clean this up, this fraction in here, over these sum of fractions. I'm going to clean it up first. It kind of helps you not to make errors if you'll write things in a nicer form. And that minus, that's going to be plus 1 over t. Okay. And now finally, I'm going to put my numbers in. So I'm going to have 2 times 9 plus 2/3 times 9 to the 3/2 plus 1 over 9, and then minus 2 times 1, and then that's going to be 2/3 because I'll put in 1 for t, and then plus 1. Ugh, arithmetic. Well, let's top it out. Actually, this is the answer right here. That's a number. It's okay with me if you stop there. Okay. So 2 times 9 is 18 plus 2/3, and then we have the square root of 9, which is 3 cubed, so that's going to be 27 plus 1 over 9 minus 2 minus, okay, 2 plus 1 is 3, so add those together at least. And let's see. So I've got 18 minus 3, that's 15. And I've got 2/3 times 27 minus 2/3. So that's 2/3 times 27 minus 1. That takes care of that and that. And I still have 1/9. Yeah. Okay, so that's equal to 15 plus 2/3 times 26, which is 52. 52 over 3 plus 1 over 9, which is okay, do it. 9 times 15 is 45, and 4 is 135. So 135 over 9, and then 52 times 3 is 156 over 9 plus 1 over 9. And then 135 plus 156 is 11, and 1 is 9. 291 plus 1 is 292 over 9. And my arithmetic there's checking there. But as far as I'm concerned, you can leave your answer like that. Okay? And not have to go through all this arithmetic. It's only important to do all that arithmetic if you need the number in order to do something else.
Would that 292 over 9 include the 2 plus 2 over 3 plus 1?
Yes. Because I took the 2 and the 3 and I got minus 3, but I added that to the 18 to get 15. And I took the 2/3, 27 minus 2/3 and factored out the 2/3. And that's where that 27 minus 1 came in. And then you had that 1/9 hanging out there.
Oh, okay, thank you.
Okay. Well, okay. Check my arithmetic on the rest of this. Okay. But this is right. All right. Let me just let's do, do we have time? No, I don't think so. Okay. Maybe I will start. Well, I'm gonna do another velocity problem actually, and talk about net. Well, let's this theorem down. Net change theorem. So that's your kind of total change, and you may go up, you may go down, but the change from where you started to and where you ended, that difference. That's basically says the definite integral from a to b of f prime of x dx. So the antiderivative of a derivative. Okay. Well, this is by the second part of the fundamental theorem, f of b minus a. And this is what you call your net change in f over the interval a, b. Okay. And we're going to apply this to a couple of problems tomorrow. But I think that's enough for today. Let's see. Hang around. If you've got questions, otherwise you can.
All right, I'm gonna chat that your audio is still not working.
Okay.
It goes pretty much slideshow.
Okay. Oh, I'll see what I
Bye.
do. Bye-bye.
Have a good day.
You too.